Hello and welcome back to another video. In this problem, we're asked, given that the limit as x approaches pi of cosecant squared x is equal to infinity, illustrate definition 6 by finding values of theta that correspond to m is equal to 500 and m is equal to 1000. So what does this mean? What is definition 6? Well, it's the precise definition of an infinite limit, which states that the limit as x approaches a of f of x equals infinity. This statement means that for every positive number m, there is a positive number delta such that if 0 is less than the absolute value of x minus a is less than delta, then f of x is greater than m. So what is this saying? Well, if we plug in pi for a here, we get that 0 is less than the absolute value of x minus pi is less than delta. So if we ignore this, if we just have the absolute value of x minus pi being less than delta, this means its magnitude is less than delta, which means that x minus pi is less than delta and greater than negative delta. And if we say that the absolute value is greater than 0, that's only excluding the fact that the absolute value could be equal to 0, right? This is saying normally it's implied every single absolute value is greater than or equal to 0, right? Because you can't have a negative absolute value. So therefore, we're only excluding when x is equal to 0, or sorry, x minus pi is equal to 0, in which case x is equal to pi. And since we're dealing with the limit as x approaches pi, we don't actually care what happens at pi, which by the nature of this limit, we can assume is just that it's undefined. So we can just ignore this altogether and simply state that adding pi here, that x, with this canceling, is less than pi plus delta, and it's greater than pi minus delta. And we're saying that there is a value delta for which if x does not go further than delta from pi, right, then f of x is greater than some value. We're starting out with 500. So we're saying within a certain bound, all the values are greater than 500, and therefore we can assume that it goes off to infinity. So what we're going to do here is now we have to find this value. So we have the graph of the function here. And we are looking at the limit as x approaches pi, which we can pull up right here, is this line here. And we can sort of see that, you know, as we're getting further and further, we have these two green lines that are sort of going off to infinity as they approach this value. And so what we have to do is first zoom out a little bit so we're not scrolling for 15 minutes. We have to do is go up to where the value of the function is 500, which is very difficult to do because of how dense this function is, and say, okay, how close to our value of pi, which is this purple line right here, is the function at this point? So if we zoom in here, right here we have 500, right? This is the point where we have y equals 500. At this black line, we have these points right here. So we have 3.0969 and 3.186. So x is between 3.186 and 3.0969. And we're saying if within this range, all the values are greater than 500. So if pi minus lambda equals 3.0969, what is lambda? Well, you have to plug it into your calculator because we have to get the exact value of pi. But when you do that, we get that lambda would be equal to 0.0447, roughly, of course. And if pi plus lambda equals 3.186, then we would get that lambda equals 0.0444. So we're basically saying if you go in one direction, then we're going to drop by drop below 500 if you go this far. And if you go in the other direction, it'll take this far. And so we have to take the smaller of the two values, because if we go 0.447 in this direction, the direction of the positive direction, we'll be dipping past this 0.444 mark and going below. So you take the smaller value. And again, this is saying as long as you stay this close to x is equal to pi, then f of x, our function here, is going to have a value greater than 500, and therefore we can assume that its limit goes off to infinity. So we also have to do this with 1000. So we have to check f of x being greater than 1000. And doing that, similar thing, we have to pull it up on the graph. So if I can just do that, it's going to take a little bit, just because, this software isn't really built for this. But if we see right here that we have the function here at y equals 1000, right? We can see this red line right here. At this point, the functions are still approaching, and they're a certain distance away from the value of x is equal to pi. And so you'd be tempted to say, okay, this is this distance, 0.032, this is this distance, 0.6315. What we actually have to do is zoom in really, really close, because they're actually very, very close to this value. And we can see that we have 3.173 and 3.11. So for f of x to be greater than 1000, x has to be between 3.11 and the other value, let me just pull that up again, 3.173. So therefore, pi minus delta is equal to 3.11, pi plus delta is equal to 3.173, and again, I'm gonna have to pull out the calculator because pi is an irrational number. You can't just subtract in your head. So we have pi minus 3.11 is 0.316, and if the thing is 3.173, delta is 0.0314, which leads me to believe that yes, I did miss a 0 here, because there wouldn't be a crazy difference on both sides. So once again, we're going 0.0316 in one direction, 0.314 in the other direction. And so we have to pick the smaller, the more restrictive value of delta, 0.0314.